Discuss wind. Already we have discussed wind, so today we will just show you the closer look. So this is overall a cross section of the wind. The probably the picture is not so good. Basically, wind energy, the NASA has made this wind energy as wind energy conversion system, WECS. NASA has made this term wind energy converter system. Okay, and there is not that only one wind turbine is established. There are several wind turbines, several, and all the wind turbines when connected in a serial way is known as wind farm, also known as wind farm. Okay, so these are the blade connection. These are the blade connection that and how the blade will be. Some blades are there's the vertically and some are horizontally. So there are two configuration. One is horizontal axis configuration. Horizontal, you see that the basic fan structure, and a different structure is that this vertically it goes vertical. So these are different the still the scientists are researching that which configuration is good for harnessing the more wind energy. So as I'm already said that this slide is not important for your exam, probably you will not face many questions from this slide, but very important for your thinking process. The energy can be something like that. So you see that so this is the closer look. This is the closer look of wind turbine system or wind turbine power plant. Okay, you see that this is the blade, we already know. This is a very closer look, and this is the different structures. These are all the blades. The basically blades are connected in the low shaft. We said that in the last class. There's a wind turbine or wind blade can maximum rotate 40 to 60 times per minute, but our generator require at least 1200 rpm or to 1500 rpm or 1800. So that is used to cope up that speed. We need a gearbox. So you see that in between a gearbox. So this is low speed shaft, this is high speed shaft. So this gearbox is basically that adjusting that speed, that low speed to high speed to the generator. So you see that, and here known as blade pitch control. This is such a control where this blade can also rotate. Okay, the blade can also rotate according to the wind speed. And here you can see wow control. Okay, wow control. Here the whole structure can rotate 360 degree. This structure can rotate 360 degree. How? When the speed is the wind direction is changing from here to there, then it can rotate and go to the exact wind direction for harnessing most energy. Okay, so you see that this yaw control here, this structure, it is just used as I'm showing you the figure where this figure here in this position. So it can rotate the whole structure and move to the wind direction to harness the main energy. So this is the closer look, and here these slides, the different components description is given. You can read, but not necessary. You can read. Definitely you can read for your understanding. So just gearbox, I want to see you that basically the wind turbine rotor can range from 40 rpm to maximum 400 rpm depending on the models on the wind speed, but generator are typically require rpm of 1200 to 1800. That's why the gearbox is basically used. So gearbox can connect the low speed shaft to the high speed shaft. You can understand the function of the gearbox. So the main two important thing is that wind speed and wind direction, because we know that the wind speed is also not fixed. the wind direction is also not fixed. So we need to cope up, we need to identify that wind speed, what is the wind speed right now, and accordingly to adjust that wind turbine. So there is anemometer, this structure, this cup structure, something like that. This structure rotates. You can see the weather department of a country, this type of structure rotates and try to find out the wind speed. What is the wind speed currently? So this is known as anemometer. Okay, so when it is rotates, it creates the rotating torque, and from that rotating torque we measure the wind speed. Okay, so according to the wind speed we adjust the gearbox, so wind speed measurement is, you know, created by this anemometer. Next is wind vane, that is used basically the wind direction measurement. Okay, this is a very thin structure. This thin structure is, you know, used to identify the wind direction. So when it is settled to the, it is created in such a way that it settled in the same direction where the wind is flowing, in which direction. So basically, when according to its position, the wind turbine turns and rotates into the wind direction, because as the direction of this vane is the same as the direction of the wind, that's why the at first we measured the direction of wind from this wind vane and then turns the whole structure in front of the wind to harness the maximum energy. Okay, so this is the way of wind direction measurement, and the anemometer is the wind speed measurement. This is just the statistics of see that just the classification of different types of wind turbine: small, intermediate, large. So basically it is, you know, divided according to the capacity. When the wind turbine capacity is less than 10 kilowatt, the 10 kilowatt, at that time it is known as small. When the capacity is 10 to 250 megawatt, sorry, 250 kilowatt, not megawatt, 10 to 250 kilowatt, it becomes intermediate wind turbine. And when the crosses 250 kilowatt to 2 megawatt, okay, so at that time it becomes central and large wind turbine. You see that this type of, you see the figure, and that this type of lots of wind turbines are presented. In the first we discussed that what is wind farm. Wind farm is basically, you know, series of wind turbine. You see that series of wind turbines are presented, so it harnessed the energy. So all the wind turbines are combinedly known as wind farm. You see a example. This is the practical London Array, known as London Array, the world largest offshore wind turbine. It has 175 wind turbine in the Thames River, London, in the Thames River, and it generates 630 megawatt, huge electricity, 6030 megawatt power, and it provides more than 470,000 homes, two-thirds of the homes in the Kent city. The Kent city is just near the Thames River. So from this wind energy, they are providing two-thirds people of that city. So there is a huge power. You know, you are not wasting your environment, just the plotting those wind turbine in the seashore or the river. Okay, so, you know, so the London has been one of the interesting place where this renewable energy has been harvesting so much, the wind energy basically. So you see that the potentiality, there are, you know, It is predicted that 2030 the renewable energy will be the 28% of the total power consumption from either coal or oil or gas. 28% will be renewable energy, and among that renewable energy 27% will be the wind energy. After the, it will be the second largest. The first one will be the solar energy. The second one will be the wind energy within the 2030. It's a statistics made by different scientists. So sir, what are the advantages of wind power? There are some advantage and it should be understood. No, uh Hamza said that, sir, can wind turbine, um Hamza's question was, sir, the wind turbine can work without wind vane? Yes, it can work. It can work, but why the wind vane is used? Basically, suppose we all know that the wind always try to flow from the south direction. So we placed the whole wind turbine towards the south. So suppose the wind direction changes. Now the wind direction changes and it is flowing from east. So at that time, your blade, the blade of the wind turbine is not getting the force from the wind, because the direction it should be, now it has changed. So for that reason, the whole wind turbine should be turned, should be rotate to the east. At that time it will get the force from the wind. So to rotate to the east, how the wind turbine will understand? So wind vane is used basically to find out the wind direction. So the when the wind has been changed its direction, the wind vane will also change its direction, and when the wind vane is changed, the whole structure will follow the wind vane position and rotate to the east. That's how the optimum use of wind turbine has been, monitored or facilitated. I think you got your answer. Yes, it can work, but it cannot work properly. So the advantage, we are talking about advantage. Basically, the generation of electricity by wind turbine does not involve any kind of carbon dioxide emission, pollutant that cause rain, smoke. So basically, it is a totally clean energy. The wind also blows day and night, so whole 24 hours. So there is no problem such like night, and just like solar energy. And also, you know wind energy, when we have it, has a very little impact on the environment. And if we place the wind turbine, the land is still usable, because the only one structure which has been used to the very upward, so the land can also be using. So in our country such like that, we have lands shortage, so we can also place wind turbine, and the land we can also use for irrigation or something else. So the land is also using. And also one more advantage is that day by day the cost of wind power is decreasing. So when the cost is decreasing, so the more people, the more country are being interested in the wind turbine setup. Okay. So wave energy. Next, the wave energy. So wave energy is basically very interesting. Very interesting. You definitely search the video in the internet, then you will find out that the different wave energy. Give me 1 minute. So hello.
Hello.
Okay.
Okay.
Okay, we're
Okay, we're
starting.
starting.
So
So
basically,
basically,
wave
wave
energy
energy
is not
is not
using the
using the
wave.
wave.
Using the
Using the
wave of
wave
the
of the
sea, we
sea, we
harness
harness
energy. It's
energy.
very
Very
interesting type
interesting
of
type of
energy,
energy,
basically
basically
used
used
or been
or been
harvesting in
harvesting
the
in the
Australia. The
Australia. The
ocean
ocean
energy
energy
has been
has been
using
using
more in the
more in the
Australia.
Australia.
You see
You
you
see
search the
the
video,
video,
you search in the
search in the
YouTube the
YouTube
what is
the what
wave
is
energy.
wave
You
energy.
can
You
see
can
the
see the
different
different
types of wave
types of wave
energy,
energy,
and there are
and
different
there are different
techniques of
techniques of
harvesting.
harvesting.
So
So
today we
today
will,
we will,
it's just
it's
just the
just the
introductions. It's
introductions.
not
It's
like
not
that
like that.
these are
It's very
important for
important for
exam.
exam.
Just the
Just the
introductions.
introduction.
How
How
they
they
created
created
vessel.
vessel.
They
They
created
created
vessel
vessel near
near the
near the
beach.
beach.
So
So
when the
when the
wave
wave
rises,
rises,
the
the
water
water
rises.
rises.
So there
So
are
there are
two
two
veins.
veins.
When the
When the
water
water
rises,
rises,
it
it
gives
gives
pressure
pressure
there,
there,
and the
and the
air
air
goes
goes
outside,
outside.
and this
This
air
air
pressure
pressure
gives
gives
heat to
heat
this
to this
turbine. So the
turbine. So the
turbine
turbine
rotates.
rotates.
So when
So
the
when the
water
water
falling
falling
in the
in the
wave, when the
wave, when
water
the water
falling,
falling,
this
this
gate is
gate is
off.
off.
So at
So
that
at that
time,
time,
it is creating vacuum of
vacuum of
air.
air.
So
So
this
this
gate
gate
becomes
becomes
open, and
open,
the
and
air
the
is
air is
entering from the
entering from the
outside, and
outside,
it
and it
also
also
gives the
gives
pressure
the
to the
pressure to the
turbine,
turbine,
and the
and the
turbine
turbine
rotates. So
rotates. So
basically, they
basically,
are
they are
using the
using the
waves
wave
and
and
air
air
for
for
harnessing,
harnessing,
electricity.
electricity.
And
And
basically,
basically,
electricity
electricity
means they
means
are
they are
using the
using the
turbine.
turbine.
They're
They're
rotating the
rotating the
turbine. When the
turbine. When the
turbine is
turbine is
rotating, the
rotating, the
electricity
electricity
generates.
generates.
I
I
cannot,
cannot,
show you
show
the
you the
video right
video
now,
right now,
but if
but
you
if you
search
search
just like the
just like the
how wave
how wave
energy
energy
work in
works
the
in
YouTube,
YouTube,
you will
you will
understand. Very
understand. Very
interesting.
interesting.
So
So
the
the
thing is
thing
that
is
I'm
that
just
I'm just
talking
talking
about
about
that
that
different kind
different
of
kind of
energy that
energy
is
that is
emerging,
emerging,
and
and
just
just
giving you a
giving you a
clue to
clue to
think,
think,
to
to
search
search
by
by
yourself.
yourself.
Okay,
Okay,
you'll
you'll
this
see
kind of
this kind of
boya
boya
structure.
structure.
This kind
This
of
kind of
boya
boya
structure. This
structure. This
structure
structure
moves
moves
up
up
and
and
down,
down,
moves up
moves
and
up
down
and
with
down
the
with the
wave,
wave,
and
and
creates
creates
the
the
linear
linear
actuation and
actuation
makes
and
the
makes the
electricity.
electricity.
Just
Just
search in the
search in the
YouTube
YouTube
how the
how
wave
the wave
energy
energy
works. You
works.
will
You
see
will
the
see the
video.
video.
Okay.
Okay.
So
So
we'll
we'll
just talk
just
about
talk
the
about the
advantage of
advantage
wave
of wave
energy.
energy.
That is
That
that
is
the
that the
large
large
energy are
energy are
available.
available.
Large energy
Large
because
energy
the
because
waves
the
are
waves are
available
available
in the
the
sea.
sea.
And
And
also we can
also
see
we can
that
see
the
that the
wave can be
wave can be
predictable because
predictable
we know
because we
that
know
the
that
wave
the wave
are
are
always
always
predictable.
predictable.
High, low
High
wave,
wave,
low
low
wave, high
wave,
wave,
high
low
wave,
wave,
low wave.
and it
And
has
it has
very
very
low
low
impact.
impact.
When
When
if we
if we
harness the
harness
wave
the wave
energy, it has
energy,
a
it has a
very low
very low
impact
impact
in the
the
environment.
environment.
Very low
Very low
impact.
impact.
The
The
no
no
chemical
chemical
pollution, pollution in
pollution
the
in the
sea will be
sea will
there,
be there.
and
And
obviously
obviously,
no
no
problem for the
problem for the
marine life
marine
because
life
we are
because we
just
are just
harvesting
harvesting
energy in the
energy in the
beach
beach
or
or
either near
either
the
near the
coastal
coastal
area,
area,
not in the
not in the
main
main
deep sea.
deep sea.
That's why
That's why
it
it
is
is
not
not
harmful
harmful
for
for
marine
marine
life
life
also, the
also,
life for
life
the
for the
fish
fish
also.
also.
So these
So
are the
these are the
advantage.
advantage.
There are some
There are some
disadvantage
disadvantages
also.
also.
The wave
The wave
patterns are
patterns are
irregular,
irregular,
quite
quite
irregular.
irregular.
Okay.
Okay.
Probably a probability that
Probability that
if you
if you
establish the
establish the
wave
wave
power
power
energy
energy
system
system
near the
near the
beach,
beach,
the
the
hurricane can
hurricane can
come, the
come, the
tsunami can
tsunami can
come. That
come. That
at that
at that
time,
time,
this
this
can be,
can be
totally
totally
destroyed.
destroyed.
And
And
the
the
more
more
wave
wave
or the
or the
much
much
more
more
power are
power
available in the
available in the
deep
deep
sea. But
but
to
to
set up
set
this
up
kind
this
of
kind of
generation
generation
setup
setup
in the
in
deep
the
sea
deep
is
sea is
very
very
costly and
costly,
also
also
very
very
uh,
uh,
time
time
consuming.
consuming.
So it
So
has
it
a
has a
disadvantage.
disadvantage.
And the
And
wave
the wave
periods are
periods
very
are
low
very low
frequency.
frequency.
There's a
There's
low
a low
frequency
frequency
according to the
according
low
to the low
frequency, so we
frequency. So
have
we
to
have to
also
also
convert
convert
that
that
for the
for the
electric
electric
generation.
generation.
The
The
capital
capital
cost is
cost is
very high,
very
as
high,
we
as
know
we
that
know
to
that to
establish
establish
something in the
something in the
sea
sea
is a
is
very
a very
high.
high.
And last
And
but
last
not
but
the
not the
least,
least,
the
the
maintenance
maintenance
cost is
cost
also
is
very
also
high.
very high.
Okay, the
Okay, the
maintenance cost to maintain that in the sea also very high. But interesting thing is that the main problem is if we establish this kind of things in the seashore, we also need to transmit this power. Okay, so to transmit this power from sea to national grid, it's very, it's very tough, very tough, because very it's very far from the land. If we establish this kind of things in the quite deep sea, it's very tough to transfer that electric power to the national grid. Okay, so that these are the difficulties, but still there are some advantages, there are some disadvantages, and the research are going on how to overcome this kind of problems, this kind of difficulties, how to overcome. So these are the emerging, not established all the way. These are the just emerging technology. Next, the tidal. Next, the tidal. Sir, we all know that what is tidal. Tidal means high tide, low tide comes in the sea. You know that the tidal power. Okay, we know that two types of tidal: high tide and low tide, and the tide happens due to the attraction of the sun and moon. You see that? You all know that the basic physics of tide. When the land mass lines up with the earth moon system, the water enters the high tide. You see that? The water enters the high tide. Moon here, it attracts the water, so the high tides are going on. We also know that the neap tide and spring tide, that the tide can happen both for moon and also for sun. Also for moon, also for sun. When the moon and the sun are in the same direction, in the same position, the tides are very high. When the moons and suns are in the 90 direction perpendicular one way each other, the tide are low. The tide are low. Okay. So basically, how this kind of tide are basically used for power generation? Basically, a basin or a deep area near the sea has been used. Something like that. Suppose this is sea, and an area where we can reserve water has been used. So when the high tide is going on, the switch gate, there are gates between this sea and this enclosed basin. Basin means an enclosed area where we can preserve the water. Okay. So in this gate, in this switch gate, the turbine has been established. So when the high tide, so definitely the water level in the sea will be higher and the basin will be lower. So at that time, the water will enter inside the basin. Okay. So when it enters inside the basin, in the gate, in the switch gate, the turbine has been established. So it gives force to the turbine, and the turbine rotates. I cannot, it's very sorry that I cannot show you the exact phase, but I'm just talking about so you can visualize and you can also search. You see that this is the way. Suppose this is C, this is our barrage or our basin. And in between the turbine happens. In between the turbine. So when the when the water level high in the open sea, so we know that higher level, from higher level the water will flow to the lower level. So the water will flow within this turbine, within this turbine. So when it flows within the turbine, it just hit the turbine and the turbine rotates. Okay. At that time, all are same level, so there will be no flow. There will be no flow. There will be no flow. Yeah, my voice is repetitive. Probably I am talking every line twice. That's why probably. No, the Yasin said the turbine is both clockwise or anti-clockwise. No, sir. The turbine is established in such a way, the position, that it always clocks in one direction. Okay, it's not that in sometimes it clocks something in one direction and up to sometimes it clocks in the both direction. No, it is situated in such a way, the turbines structure in such a way that in whether the flow, the turbine will always flow in one direction. Okay, when we have a slide, we have a topic named as turbine. Okay, there we'll see the different structure of turbine. because it is structured in such a way that in which direction you flow, it will always rotate in one direction. So there is no anti-clockwise clockwise direction, there is only one direction. So after that, when the low tide happens, the low tide happens, that means the lower level in the open sea and the barrage has high level. At that time, we open the gate, and the higher level, from higher level our basin, the water will flow to the sea. The water will flow to the sea, and it still we have to pass this turbine. So when the water flows this turbine, the turbine rotates. So in this way, it's just a way of harvesting the wave and tide energy. You can see that this structure, this type of structure. This is basically in the France, the La Rennes tidal barrage. It's a 700 meter long dam at the mouth of Rennes River, and it produces 240 megawatt electricity. Okay, 240 megawatt electricity. So this type of type of energy has been emerging, not widely popular, but no, at least a small amount of energy they are harvesting, because everyone is going for the renewable energy. So what are benefits? The benefits are there is no pollution, it's totally renewable, and more efficient because of the density of water, because the water density gives us that power. And we all know that this is the cosmic phenomenon. The tide will happen, we all can predict that. After that time, the lower tide will happen, after that time the high tide will happen. So we can predict that. In the sea we can predict that. So it gives us the predictability, not like the wave, because wave are very irregular. We don't know that how much wave will be there, how much wave will be there, but the tide is very regular. After that time the lower tide will come, the higher tide will come. It is regular. What are the drawbacks? So drawbacks is that it's very expensive to build, very expensive. And as this type of things are very far from the load center or national grid center, okay, so it's to transfer power is very difficult, very difficult. And environment effects can happen, the fish and the plant migration, this can happen because we are building some structure near the coastal area, so it can hamper the that's why you can see the fish structure. The silt deposits, yes, because it can change the direction, the way, the flow of direction of water. So that's why the silt directions, and also the local tide change, because when you are building this kind of things in the coastal area, the whole structure of the sea can change also. Okay, so these are the drawbacks, but still the scientists are trying to fix it out so that they can uh, overcome this kind of situation, and try to